Lesson 3.6, finding trig ratio given another. So there's no graphs in here, but you might find it helpful to create your own little triangles to see the numbers, or we'll try to do it with the formulas we learned in the last lesson. So we're given a tangent of angle A is this ratio. So these are sides of our triangle, and A is in quadrant 2, which just goes quadrant 1, 2, 3, 4. Find the exact value of sine of A. So we're trying to find a new ratio of the sides from that angle theta or A here in our standard position using the sine ratio. Sine is going to be is opposite over hypotenuse. Or as we learned, opposite is the y and hypotenuse is the radius. But what I wanted to do is show you just how you could draw your coordinate plane or your axes, make a triangle, any size, shape you want, in quadrant 2. From this angle, they're giving us tangent, so this would be opposite over adjacent. Opposite would be this y value over here, 16, and then adjacent would be 63. The reason why there's a negative there is because in quadrant 2, this x value, since it goes to the left, is negative, whereas this height, this y value, is positive. So the negative, you got to figure out which number it goes with. Couldn't go with both. And so now what I'm doing is finding the radius or the hypotenuse with Pythagorean theorem. Go ahead and solve that on your own. And you should get that it is 65. So then sine of A is going to be opposite, which is 16 over 65. Okay. The nice thing about seeing this is since I use 60 and 65, see how they're both positive? That tells me that my final fraction should be positive. The other way you could have done this is knowing this y over r and knowing this is your y, and then just knowing that you're trying to find your radius. But again, a picture might help you. So number 2, we're given a secant ratio. We're in quadrant 4. So that would be down here. So here's your 90, here's your angle. Find the exact value of cotangent of A. So yeah, since there's so many parts here, let's think of secant is the reciprocal of cosine. Cosine is adjacent over hypotenuse, so this is hypotenuse over adjacent. And there's a negative here for a reason, so hypotenuse would be here. And I will mention the hypotenuse can never be a negative. For 1, because it's the radius of a circle, but also for 2, because when we do Pythagorean theorem, we're squaring the legs, which makes any negatives become positive. And the adjacent leg would be our x value, which is 6. So really our y must be negative. And then I know that cotangent of A is the reciprocal of tangent, so instead of going TOA, I'm going to go adjacent over opposite. So I'm missing the opposite. I'll have to do Pythagorean theorem again. So it'd be 6 squared plus what squared equals square root of 85 squared. Square root square cancel, so that's just 85. Subtract 36 and square root that. And you should get 7, but this should be a negative 7 because this y value is going down to get to this point. And so then I would make it a fraction, so cotangent of angle A would be 6 over negative 7, or float the negative up to be negative 6/7.